Before we continue with a detailed description of the nozzle disassembly procedure, let's briefly examine the design and construction of these components now that the upper half of the turbine shell has been removed. The first stage nozzle is made up of an inner ring and an outer ring between which the nozzle vanes are assembled. These components are also known as inner and outer sidewalls and partitions. This sidewall and partition assembly is assembled inside the retaining ring. The entire nozzle assembly is split at the horizontal center line, giving us an upper and lower half. The upper and lower halves are joined at their mating flanges with bolting and doweling. The nozzle assembly is supported in the turbine shell lower half by a lug and clamping arrangement on both sides at the horizontal joint. This L seal seals the area between the inner sidewall and nozzle support ring. The L seal is actually made up of 10 segments, which are locked in place by clamping rings. The parts of this assembly which need to be removed for inspection are the nozzle upper and lower halves and the L seal segments. The second stage nozzle is similar in construction to the first stage. It's made up of upper and lower halves, bolted and doweled at the horizontal joint, supported by lugs and clamps in the turbine shell. Under the first stage nozzle, there is a nozzle support ring, and under the second stage nozzle, there is a diaphragm. The diaphragm is used to provide a seal at the turbine shaft. Both the nozzle support ring and the diaphragm are split at the horizontal center line. The upper half of the diaphragm is mated to the nozzle upper half with dowel pins at the center line. The lower half of the diaphragm is mated with dowel pins to the nozzle lower half. Before disassembly, these dowel pins are inaccessible. Therefore, the nozzle and diaphragm must be removed as a unit. So now that we have examined the construction, let's look at the procedure for disassembling the nozzle blocks. Before disassembly of the nozzle upper halves, measure and record the clearances on both sides at the nozzle support clamps. Details of this are noted in your workbook. Compare these clearances with those found on the clearance diagram supplied in the turbine instruction manual. During factory assembly, these support clamps are ground to accurately locate the nozzle in the vertical position. After recording these clearances, we can start to disassemble. At the first stage nozzle clamps, bend back the locking plates, unbolt and remove the clamps. Identify the clamps for location. Clean the bolt threads and bag with the clamps. Discard the locking plates. New plates will be used at reassembly. Remove the nozzle horizontal joint bolting. Clean the threads, tag and bag the bolts. Loosen the bolting which secures the L-seal clamping ring to the nozzle support ring. Rig the nozzle upper half to a chain fall ready for the lift. After loosening the lower L seals that overlap the horizontal joint, carefully lift the nozzle, keeping it level. If the lower half begins to rise, tap the joints with a soft-faced mallet to unstick the dowels. The crane is also attached to the lifting ring, so that once the nozzle is clear of the turbine, the lift can be transferred to the crane. The nozzle can now be lifted to the work area and placed on a pallet for cleaning and inspection. Let's now look at the procedure for disassembling the second stage nozzle. As with the first stage nozzle, remove the clamps and bolts, clean, then tag and bag. Rig the second stage nozzle upper half to a chain fall and carefully lift the upper half. Should the upper half bind on the dowel pins, lift it free with a lifting bar. Note that there are now 6 I-plates welded to the stack. These are to facilitate this and future lifts. When we have lifted the upper nozzle as far as possible on the first chain fall, we transfer to a second one attached to a higher eye plate. This enables us to clear the stack sufficiently to allow the crane to do the remaining lifting. The crane then moves the upper nozzle to the cleaning and inspection area.
Before going on to look at the removal of the upper support ring and diaphragm, let's take a short break. We'll complete the disassembly in segment B. We are now ready to complete the removal of the upper components. To remove the first stage upper nozzle support ring, first remove the shim in front of the support ring. You will recall that the bolts going through the shim were removed earlier. After removing the horizontal joint bolts and attaching a lifting belt to the chain fall, lift the half support ring. Make sure that the support ring is kept as level as possible and that it stays clear of the adjacent turbine buckets. When well clear of the turbine, the half support ring is transferred to the crane. The crane then moves it to the inspection area. Now, for the second stage upper diaphragm.
Remove, clean, tag, and bag the diaphragm horizontal joint bolts. After assembling the diaphragm lift fixture to the top of the diaphragm and rigging the lift fixture to the chain fall, lift the diaphragm, checking that the lift is as perpendicular as possible, thus preventing the diaphragm from contacting the turbine buckets. When it's lifted as far as possible with the chain fall, it's transferred to the crane. The crane then moves it to the inspection area. The diaphragm is carefully placed on a sheet of plywood, which prevents damage and allows easy inspection.
With the upper halves of the first and second stage nozzles, support ring, and diaphragm removed, we can now measure the clearances between rotating and stationary components.
Here is a typical form suitable for recording these clearances. A copy of this is included in your workbook to give you time to study it carefully. The turbine instruction manual contains a clearance diagram indicating the designed cold clearance limits between rotating and stationary components on your machine. Both initial and final clearances must be measured and logged. The initial clearances are the as-found dimensions taken at this stage of the inspection. The final clearances are those taken at reassembly. Note that when referring to location, the left or right side is always taken from the compressor looking aft. The position of the rotor must be correctly set before measuring the clearances. The rotor must be pushed forward against the active thrust bearing. Also, the number 1 rotor bolt must be positioned at the left side horizontal joint. To identify and locate the rotor number 1 bolt hole, consult the instruction manual for the exact location and stamping of this critical reference point. The clearances can now be taken on both sides and recorded. Many of these measurements may be taken with a taper gauge. However, parallel bars and feeler gauges are preferred to provide accurate measurements. The rotor is then rolled 180 degrees, thrust forward, and the clearance is taken again. When rolling the rotor, be extremely careful not to catch your finger between the bucket tips and horizontal joint. This time, the number 1 rotor bolt should be at the right horizontal joint. When measurement of the clearances has been completed, the lower halves of the nozzles may be rolled out as the rotor remains in place. First, unbolt and remove the first stage nozzle bottom eccentric pin from the shell. Install an eye bolt in each side of the nozzle assembly horizontal flanges and attach lifting tackle.
Remove the bolts in the outer support clamps on both sides of the turbine. These clamps hold the nozzle assembly to the first stage turbine wheel shrouds assembly.
Lift the assembly sufficiently so that the axial clamping blocks can be removed. Be sure to identify the clamps for proper reassembly. Unbolt and remove the lower half of the nozzle L-seal clamp ring from the first stage nozzle support ring assembly. The nuts are accessible through the combustion can openings in the compressor discharge casing. Remove the L-seals if possible, as they may fall out during the lift, causing damage or injury. Take up on the chain falls to slightly lift the nozzle. Roll out the nozzle by taking up on one chain fall and letting out on the other, and lead the assembly around the rotor. Add a third chain fall and take up on it. Move one chain fall. A lift point is exposed. Continue rolling out the nozzle.
When completely inverted, fit an eye bolt. Attach the crane and lift the lower half nozzle clear of the unit, being careful not to make contact with the turbine buckets. The lower half second stage nozzle and diaphragm is removed as a unit. Remove the second stage nozzle eccentric pin from the bottom of the turbine shell. Unscrew and remove the two lower half nozzle retaining pins from the turbine shell. Install an eye bolt in each joint flange and rig the lower half nozzle assembly for lifting. Lift the assembly sufficiently, about 40/1000ths of an inch, to remove the two lower support blocks. Remove the packing segments. They will be inspected to determine if repair or replacement is necessary. Replace the packing segments with wooden blocks to help maintain a safe distance between the diaphragm assembly and the turbine wheel joint. This is necessary to protect the wheel air deflector teeth from possible damage. Roll out the second stage lower half nozzle diaphragm assembly in a manner similar to the first stage. Make every effort to keep the nozzle diaphragm assembly as vertical as possible. Two areas must be carefully observed during rollout. First, check that the turbine shell to nozzle bobby pin seal is sliding smoothly through the groove in the nozzle outer wall. Second, make sure that the wheel space seals on the diaphragm do not contact the turbine buckets. When clear, place the nozzle diaphragm assembly on a pallet for cleaning and inspection. Block the assembly so that the wheel space seal teeth are not crushed or damaged. In this procedure, we have not removed the first stage lower nozzle support ring. It will not be removed if the inboard and outboard radial seals around its total sealing surface are within tolerance. If the radial seals on the lower nozzle support ring need replacement, follow a procedure approved by the manufacturer. All right, so now we have all of the components spread out around the work area. This is a good time for us to take a break, and then we'll come back and look at inspection procedures. For now, please switch off the tape, review this material in your workbook.